In your high school physics class, you were probably taught Newtonian gravitational theory. You knew that gravity causes things to move, but did you wonder why it happened? On a small scale, such as in that classroom, his theory held through. However, when looking into orbit and beyond the stars, Newton's theory freefalls. For instance, Mercury's ever-changing orbit could not be explained using Newtonian gravitational theory. Einstein's theory of general relativity sought to generalize what Newton's theory could not explain. Instead of looking at space and time as separate entities, Einstein looked at them as if they were one entity, space-time. The theory of general relativity looked into the space-time meshes of the universe using non-Euclidean geometry to explain why gravity moved masses. Hold up. What is space-time? Space-time is the fourth dimension, one that is not visible to us, but influences us with a force perceived as gravity. To better conceptualize this idea of a fourth dimension, imagine the top face of a sheet of paper, which has two sole dimensions, the x and the y. The two rockets on this face can only perceive these two-dimensional planes as they travel in parallel along their paths on the paper. Now, if you take that sheet of paper and you warp it like how gravity warps space-time, you have changed the way that the rockets follow their paths as they respect non-Euclidean geometry. As the rockets travel along their intended parallel paths, the curvature of this third dimension makes their paths intersect. This bend in the paper results in the sensation of an attractive force, which brings the rockets together. In our universe, this sheet of paper is a mesh called time, and it is the fourth dimension. We can observe the other three dimensions, the x, y, and z, but just like how the rockets could not perceive the sheet of paper warping, we cannot perceive time warping. When our mesh of time is warped by gravity, we run along the curves that follow non-Euclidean geometry. This stimulates our experience of gravity as the paths of masses intersect, instead of them attracting one another. This further works into special relativity, where a change in the paths taken and their lengths affect the speed of time that an observer perceives. Einstein's conceptualization of how masses influence the mesh of time and space allows for us to use technologies like GPS, which work around the dilation of time, and for us to study galaxies that are far away.